So in this case, if you want to multiply A and B together, you need to consider one thing. Anytime you want to multiply two matrices together, you have to take note of this. That is, whatever you have on this row must be equivalent to whatever you have against this column, this first column. First row, first column must be balanced. How many digits do you have for this first row? Just 2. And how many digits do you have for this first column? Just 2. So you need to understand this basic concept. What if you have a matrix of this form? 1, 2, 3, 5, 4, 6. And I have matrix B as 2, 4, 6, 3. Now my question is, does this multiplication exist? Absolutely no. It does not what? It does not exist. Do you know why it does not exist? On this row, you have how many digits? 1, 2, 3. You have 3 digits. And on this column, first column, how many digits do you have? 2. You can't multiply 2. You can't multiply this 3 against 2. It's not allowed. Okay? It is not possible to get the final result to this, because if this one multiply 2 and this 2 multiply 6, then this 3 will multiply what? We don't know. So it's not possible. So it does not work that way. So that means that if I have another question of this form, 2, 4, 6, 1, 3, 2 times 1, 2, 4, 5, 1, 3. So does this, if B is equals to this, so does this exist? Yes. A times B exists. Is that not correct? Yes. Because on this first row, you have 2, 4, 6. And on this first column, you have 1, 4, 1. You have 3 digits, you have 3 digits. So you can go ahead and multiply. So you have to take note of that rule. Okay? Because not all products do exist. So in this case, I need to multiply this and this. Okay, what is A times B? That's the question. You need to use this first row to multiply this first column by saying, okay, this first digit will multiply this first digit. The first digit in the row will multiply the first digit in the column here. 2 times 1, that is 2. Okay, and then 1 times minus 3, that's minus 3. So I'm done with that. Just pause for now. And then the next thing for us to do now is to use this row to multiply this second column, because you're actually multiplying A against B. So this first row will multiply these 2. First row against these 2 columns. If you have another column, you go ahead again. So now this first 2, this is 2, multiply this minus 2. Now to consider this first row and this second column. So this 2 multiply this minus 2. That will give us minus 4. And then this 1 will multiply this 4. 1 times 4, that is plus 4. Do you agree with that? So then you stop, since we don't have any other column again. Now we need to come down to the second row, this particular row here. So 5, this second row will multiply this first column. 5 times 1, that's 5. 3 times minus 3, that's minus 9. So the same thing is applicable to 5 times minus 2. This second row will multiply this second column. So 5 times minus 2 is minus 10. And then 3 times 4 is 12. So then you go ahead. The result here gives minus 1, 0, minus 4 plus 4 is 0. This gives minus 4. And this gives what? This gives 2. So this is final answer to this. So what if you try B cross A? B times A is 1 minus 2 minus 3, 4 times. And my A is 2, 1, 5, 3. So will they be equal? They can never be equal. So take note of that. It can never be equal. So you can try this as a classwork and then consider whether whatever you have as your B cross A is also the same thing as this. So you have to take note of that. So just take note that whatever you have here can never be equal to this one. A cross B, which is the product, can never be equal to what? B cross A. It can never be equal to each other. And also take note, for multiplication, sometimes they use times, sometimes they use dots. So be very careful. Dot also means A times B. And sometimes they use AB to represent their products. A dot B, A times B, and AB. They all means the product row of that matrix. Okay, so that's just how it works.